3, 4, 5, and 8. Okay, first part is rationalizing. 5 plus 6 root 5 over 6 plus root 5 times 6 minus root 5 over 6 minus root 5. 6 5 is 30 minus 5 root 5. 6 6 36 root 5 and 6 5 is 30 over a square minus b square. 30 minus 30, 36 minus 5 is 31 root 5 and 36 minus 25 is 11. I'm just making a quick check on calculator. Root 5 over 6 plus root 5. Getting only root 5. Let me check. Where's the mistake? 5 6 is 30. As it is, and changing the sign, 6 5 is 30 minus 5 root 5. 6 6 is 36 root 5 and 6 outside. 6 5 is 30. Denominator says a square minus b. Oh, that was 5. It's not 25. Square of root 5 is only 5. So this is 31. Cancels out. And root 5 only. B part says show that this into this can be written in the form this. Okay. So when I have 1 by 2, 0.5, this could be written as 3 raised to the power 1 by 2 into 2 raised to power 7 by 2. So this 1 by 2 thing could be taken out as common. Either I write 3 1 by 2 into 2 raised to power 7 and 1 by 2. So 2 raised to the power 7 is 128. 3 power 1 by 2 into 128 power 1 by 2. So collecting the powers 128 into 3 is 384. Without using calculator. Okay, okay. That is a number, a root, two. That was 3 raised to power 1 by 2 into 2 raised to power 7 by 2. And if I write 3 into 2 raised to power 7, 1 by 2. And split this into 2 raised to power 6 into 2 raised to power 1 and 1 by 2. So only if we deal with, like I'm going to put this power on everyone. This is 3 to the 6 into 2 raised by 6 and 1 by 2. So this cancels out. 2 cube is 8 into root 6. 8 root 6. C part where A is greater than B. C part says solve the equation this. Give me your answer in simplest form. I'm multiplying the whole equation with x. So this gives me x square plus square root 2x is equals to 4. Rearranging x square plus square root 2x minus 4 equals to 0. I'm using quadratic formula. Minus b plus minus square root b square minus 4ac over 2a minus b plus minus b square is 2 minus 4 into a is 1 and c is minus 4 over 2a minus square root 2 plus minus that 4 times 16 plus 2 is root 20 by 2. Mm, x square plus 2 root x is equal to 4 minus 4 root 2 plus root 20. 2 10 times 2 5 5 1 2 root 5. So minus square root 2 plus square root 20 by 2 and minus root 2 minus root 20 by 2. So root 20 could be written as 2 root 5 minus root 2 plus root 5 by 2 and minus root 2 minus 2 root 5 by 2. And just making a quick check. That's it. Okay, we had question 3 and then 4. Given that p raised to the power 1 by 3, q raised to the power negative 1 by 2, r power 3 by 2 over this is equal to this, find the value of each. Okay. P is 1 by 3, q is negative 1 by 2, r is 3 by 2. And in denominator, p is negative 2 by 3. All those instructions. 1 is done, 2 is done. Okay, only in 3 calculator was not there. We can use calculator in this. Now q raised to power 5 and then root. So basically q is 5 by 2. R raised to power 5 and then root. R is 5 by 2. So we subtract p raised to power 1 by 3 minus 2 by 3 is 2 by 3. Q raised to power negative 1 by 2 minus 5 by 2. R raised to power 3 by 2 minus 5 by 2. So that's p raised to power 1. Q raised to the power 1 by 2 and 5 by 2 is 3 and r raised to the power 3 by 2 minus 5 by 2 is minus 1. A is equals to 1, B is equals to minus 3 and C is equal to minus 1. Question number 5 without calculator. In this question, all lengths are in centimeters. The diagram shows the trapezium ABCD in which angle ADC is 90 degrees and AB is parallel to DC, given that AB is this, DC is this and AD is this. Find the perimeter of the trapezium in giving answer in simplest form. Okay. For the perimeter, I also need the length BC. So I'll be applying Pythagoras theorem to get BC first and then we'll go for perimeter. So basically this is 7 plus root 5 and this length only should be difference of these two. So 11 plus 2 root 5 is the longer side minus the shorter side 4 plus 3 root 5. 11 minus 4 is 7 and this is 2 root 5 minus 3 root 5. Oh, that is going to be tough and do not use calculator. BC is not given in question. Find the perimeter of the trapezium. Find the area of trapezium. Okay. Okay. How to use Pythagoras theorem on it? These are three terms. Oh, that could be simplified. This is 2 root 5 and 3 root 5. So 7 minus root 5. 7 minus root 5. Okay. So working for BC first. BC squared is equals to 7 plus root 5 square and 7 minus root 5 squared whole square root. A square times 7 is 49 plus B square plus 2AB. On the other side, A square plus B square minus 2AB. 14. So negative positive cancels out. And 49 plus 5 is 54 times 2 is 108. And again, without calculator, 108, 2, 54, 2, 27, 3, 9, 3, 3, 3, 1. So 1 pair, 2 pair, 2 3 is a 6, root 3. Now for perimeter, we can add all sides. First one is 7 plus square root 5 plus 11 plus 2 square root 5. The one at the top is 4 plus 3 root 5. Last one is 6 root 3. So 7 and 11, 18, 19, 20, 21, 22, 22 and 6 is 20. No, only the first three. 7, 11 and 4. 3 integers is 22. And then root 5, root 5, root 5. 1, 2, 3 and 6. 6 root 5 plus 6 root 3. And this is the perimeter. I'm quickly just making a check with calculator in the first part. A square plus 7 minus root 5 b square. Square root answer was 6 root 3, correct? Okay, and now it says the area. Area is 1 by 2. Sum of parallel sides 4 plus 3 root 5 plus 11 plus 2 root 5 times height 7 plus root 5. 1 by 2, 11, 12, 13, 14, 15 plus 3 plus 2 is 5 root 5 times the 7 plus root 5. Keeping 1 by 2 outside, 15 into 7 is 105 plus 15 root 5 plus 7 5 is 35 root 5 plus 5 5 is 25. 1 by 2, 105 and 25 is 130 plus 15 plus 35 is 50 divided by 2 is 65 plus 25 root 5 unit square. Our lengths are in centimeters. Centimeter square, and the last one was centimeters. 3, 4, 5, and then we had 8. Given that this can be written this, we just have to collect them. P raised to the power 3 by 2, R raised to power 2 into 3 by 2 is just 3, Q raised to power 1 by 2, R raised to power 1 by 2, and denominator as Q squared, P raised to power minus 1, and R raised to power minus 2. I can see P two places. 3 by 2 minus 1 is plus 1. Q is 1 by 2 and R is at 3 places. So numerator, that is basis same, powers add, and minus minus 2 will be plus 2. And no such instructions of calculator. So 3 by 2 plus 1 is 5 by 2. And Q is negative 3 by 2. And R is 3 plus 2 plus 0.5 is 11 by 2. A is equals to 5 by 2. B is equals to minus 3 by 2. C is equals to 11 by 2. Done. Question 8. That was only a part. Anything else out of these?
These ones, I thought this would take like the whole class, but I had other like PDFs that
Yeah,
were
sure.
questions.
Sure.
I'll just find them. 5 minutes. Unfortunately, it only lets me put one file. I've been trying to put like the other PDFs that I had, but it only let me put one of them, and I just sent it right now.
Okay, let me check. File number 7. Logarithms and functions. Okay. Which question?
Let me check for my email. I sent it. It was question 7, 8, and 9.
7, 8, 9. Okay. Solve LGX is equals to 3. So this is just x is equals to 10 raised to power 3, 1000. Write LGA minus 2 LGB plus 3 as single logarithm. So this is LGA minus 2 goes on top. That's LGB squared plus that's 3. So I'm writing it as 3 LG10. Base is understood 10. So that's 1. So LGA minus LGB square plus LG10 raised to power 3. So whenever we are in multiplication, in addition we multiply, in subtraction we divide. So that is going to be A times 1000 over B square. 1000 A over B square. As single logarithm, I also have to write log. This is one way, and yeah, this is it. Solve this multiplying with x. That's x square minus 5x plus 6 is equals to 0. So it has to be 2 and 3. X square minus 2x minus 3x plus 6 equals to 0. X common, x minus 2 minus 3 x minus 2 x minus 3 into x minus 2, x is equals to 3 and x is equals to 2. And show all your working and find the value of a such that this plus this is equals to 0. Okay. Log a to base 4 minus 5 plus 6 log 4 to base a is equals to 0. Now this would include change of base law, a4 and 4a. So log a to base 4 minus 5 plus 6, that is 1 over log 4 log a to base 4, base changes. Now for ease of writing, I'm writing this whole thing as x. Log a to base 4 is equals to x. X minus 5 plus 6 over x. And if you would compare, x minus 5 plus 6 over x is exact same equation, which would result in x is equals to 3 and x is equals to 2. So log of a to base 4 is equal to 3 and log of a to base 4 is equals to 2. 4 cube is 64 and 4 square is 16. So a is either 64 or 16. Question 8. The number B of certain type of bacteria at time t displays days can be described by this. Find the value b when t is 0. Simple substitution. 200 e raised per 2 into 0 plus 800 e raised per minus 2 into 0. 200 plus 800 is 1000. At time 0, initial amount is 1000. And question 9. Do you have time? We can complete this if you have time.
Yep,
Any
sure.
consecutive? Okay.
Yep.
The population P of a certain bacterium T days after the start of an experiment is modeled by P is equal to 800 e raised by kt, where k is constant. State what figure 800 represents in this experiment. So when time will be 0, it will be 800. So it is the initial amount. It is the initial population. Given that the population is 20,000 2 days after the start of the experiment, calculate the value of k. So t was days. P is equals to 800 e raised to power kt. Population is 20,000 is equals to 800 e, k is unknown, and this is 2. So 20,000 divided by 800 is 25. I'm taking square root on both sides. E raised per k is equals to 5 and implying ln on both sides is k ln 5. So k is ln 5. A quick check. I'm substituting the same value in the initial equation. K is 2 ln 5 and I'm getting 20,000. Yeah, that's right. Calculate the population 3 days after the start of the experiment. So that's 800 e raised to power kt. 800 e raised to power k is ln 5 and this is 3. 800 times e raised to power 3 into ln 5 and 1 lakh. Done. Did you get these?
Yeah, okay. Because I was confused about the first one, about like the initial, but now I understand.